Hello there, this is Unit 12, Lesson 7. This is the angle formed by a tangent and a chord. Let's get to the do now. I actually started a little bit ahead of you, so if you need to pause the video at any point, if I'm going a little bit too fast, please feel free to do so. In the figure given, the three segments are tangent. Well, remember, tangent is a line segment that touches a circle in one place, and also remember that tangents drawn from the same external point are congruent. So the segments are tangent to the circle at points F, B, and G. Determine the length of line segment DE. So our final answer is going to be the length of this yellow segment and this blue segment added together. So I love circles. It's like a little puzzle piece. Well, if the length from C to B is 2 meters, then the length from C to F is also 2 meters. And if the length from C to E is 6 meters, then the length from F to E is going to be 6 minus 2, which is 4. And if the length from F to E is 4, then guess what? The length from E to G is also 4 meters. Now we need to find the length of BD. Well, the length from C to D is 5 meters, so 5 minus the 2 meters here is 3, which means if BD is 3 meters, then GD is also 3 meters. So therefore, the segment of DE is going to be equal to 4 plus 3, which is a total of 7 units. Ah, this is so fun. An angle formed by a tangent and a chord and a tangent, or a tangent and a chord, either way, half the degree measure of the intercepted arc. So for example here, this line segment AB is a chord. Okay, it's a line segment that touches the circle in 2 places. The line segment from B to C is a tangent because it touches a circle in 1 place. Well, this angle here intercepts arc BA, which happens to be 120 degrees. So to find the value of x, we're going to take 120, we're going to divide it by 2, and we're going to get 60 degrees. Ah, so easy. All right, let's try another one. Given the diagram below, it says explain why the measure of angle DCB is equal to the measure of angle DBE. Well, let's take a look. Angle CB is this angle right here, formed by a chord and another chord. Ooh, that's an inscribed angle. So angle DCB is going to be equal to half of the intercepted arc, which is going to be this arc right here, which is going to be DB. And then if we take a look at the second angle, it's angle DBE. So D to B, that's a chord, and B to E, oh, that's a tangent. And we know that an angle formed by a tangent and a chord is also half the intercepted arc. Well, guess what? Angle DBE intercepts arc DB. So therefore, angle DBE is also going to be half of arc DB. So that's why these two angles are congruent, because whatever arc DB is, both of these angles will be the same measure. And here's example number 1, given circle A. So that's really important right there. A is the center of the circle because circles are named by their centers. So a lot of times that's an important piece of information to find diameters and whatnot. It says determine the measure of the angle labeled A in each of the following. So I went ahead and highlighted. This is angle DCB, and it's going to be half of arc DB. Well, guess what information they gave us? They gave us the measure of this angle here, 67, and that angle is formed by a tangent and a chord, which is also half of the arc. So therefore, angle A is going to be 67 degrees. Let's take a look at the next one. This is angle DFB, and that's going to be equal to half the measure of arc D. Well, what did they give us? Angle 67 here, which is formed by a tangent and a chord, which is also half of arc DB, which means this angle is also going to be 67 degrees. And the last one is going to be DFB, which is going to be half of arc, you guessed it, DB. And guess what they gave us? This angle of 67, which is formed by a tangent and a chord, which is also half of this same arc. So therefore, this angle will also be 67 degrees. So an inscribed angle and an angle formed by a tangent and a chord, if they intercept the same arc, they'll have the same measure because they're both half the arc. Example number 2. Given circle A, again, that's really important. A is the center. Circles are named by their centers. Determine the measure of the angles labeled A, B, and or C in each of the following. These are so fun. They're like a little puzzle. Okay, so what I did down here is I put a couple of things that you might need to remember. Inscribed angles are equal to half its arc. Angles formed by a tangent and a chord is half the arc as well. And if these two are intercepting the same arc, then they're going to be congruent. Central angles equal the arc. Diameter divide the circle into two semicircles, which are 180 degrees each. And the triangle sum of the three interior angles is equal to 180. So these are things that we might be using as we move forward. So starting with part A, it says find the measure of angle A. So what do we have? We have this angle A, which is actually an inscribed angle, which means it's going to be half its intercepted arc, which is going to be half of arc BC. So then I go, well, what did they give me? Well, they gave me this angle of 34 degrees, which is an angle formed by a chord and a tangent, which is also half of this arc. So therefore, angle A is also going to be 34 degrees, which is going to be half of this arc, which if you wanted to figure it out, would be 68. Next, they said, find the measure of angle B. Well, angle B happens to be with the vertex on the circle, and the two sides are chords. That's also an inscribed angle. So it's going to be half of this intercepted arc, which is from C to E, which I don't have right now, but guess what? A is the center of the circle, which means that this line segment here is a diameter. And the diameter breaks the circle up into two semicircles, which are 180 degrees. So if I take 180 degrees from E all the way to B, and I subtract out this 68 degrees from here, I end up with 112 degrees. So if arc EC is 112, then angle B is going to be half of that. 112 divided by 2 was out to be 56 degrees. And then the last thing they want us to find is the measure of angle C, which is another inscribed angle. It's the vertex is on the circle, and the two sides are chords. So it's going to be half its intercepted arc, which means angle C is going to be half of arc DB. Well, how am I going to get that? Well, if I take a look here, they gave me this 52-degree angle, which happens to be another inscribed angle. So that means that that inscribed angle is going to be half of this intercepted arc. So therefore, I know that these two inscribed angles are going to intercept the same arc, which means angle C is also going to be 52 degrees. Or you could have said 52 times 2 is 104, and then angle C is half of 104, which is 52. So to recap, angle A is 34 degrees. Angle B is 56 degrees, and angle C is 52 degrees. They're all half of the intercepted arc. All right, here is part B. It says find the measure of angles A, B, and C. So here's angle A, and it looks like that's all I really need to find in this one. So what did they give me? They gave me this 106-degree angle, which is formed by this tangent and this chord. But even if I extend this out, I don't know exactly where that ends up. But I do know that this line segment is a diameter. And a diameter is made up of two opposite radii. So this is a radius, and this is a radius. And actually, this segment here is also a radius. Well, there's a lot of radii going on here. So this segment is equal to this segment is equal to this segment. All right, so let's see what they gave us. They gave us the measure of angle DBC to be 106 degrees. Now I know that this angle is formed by a tangent and a chord, which means that the entire arc from C all the way over to B is going to be twice 106. So if I take 106 degrees and I multiply that by 2, I know that the distance from C all the way to B is 200, and I know that the distance from C to this point is 180 degrees. So this is step 1. Then step 2, we're going to take 212, and we're going to subtract 180, and you're going to end up with 32. So that means that the distance along this arc here is going to be 32 degrees. So that's going to help us find the measure of angle C, which is another inscribed angle. So an inscribed angle is going to be half its intercepted arc. So that means that this angle C is going to be half of 32. So step 3, we're going to take 32, divide it by 2, and you end up with 16 degrees. So what did we say before? We said that this line segment from A to C is a radius, and we said this line segment from A to B is also a radius, making this an isosceles triangle, which is a triangle with two congruent sides and two congruent base angles. So if the angle across from this congruent side is 16, then angle A across from that side is also going to be 16 degrees. And here is part C. So ultimately they want us to find angle A, which intercepts arc BD, which is going to be a central angle equal to the arc, and they also want us to find angle DEB, which is an inscribed angle, which is half of this arc DB. So we have to find the measure of this arc DB. So what I did is I highlighted this 137-degree angle, which is formed by a chord and a tangent. So this entire angle is going to be half of this intercepted arc. So that whole part of the circle is going to be 137 times 2, which comes out to be 274. Now there's 360 degrees full circle. So if we take 360 and subtract out 274, that was step 1, this is step 2, you end up with 86. So the measure of arc BD is going to be 86 degrees. So angle A, which is a central angle, is 86 degrees, and angle B, which is an inscribed angle, that's going to be half of this arc, is going to be half of 86 degrees, which is going to be 43 degrees. And here's example number 3. It says determine the measure of the angle labeled A, which is right over here, and the measure of angle DBC. So let's start out with what did they give us? They gave us the measure of this angle here, which is 57 degrees, which is formed by a tangent and a chord, which means it's going to be half of this intercepted arc, which means the arc will be 57 times 2, which is 114 degrees. They also gave us the fact that these arrows represent parallel lines. So this line and this line are parallel. Well, if we connect them, forming that letter Z, then I know that the measure of this angle, 57 degrees, is also going to be the measure of this angle here. So angle, BDC is going to be 57 degrees. Now this is an inscribed angle, which means it's going to be half of this intercepted arc right over here. So that means that this arc here is going to be 57 times 2, which is also 114 degrees. So when they ask me to find angle A, which is this angle here, angle CB, that's a chord, down to N, that's a tangent, this angle here is going to be half of its intercepted arc. So angle A is going to be half of 114, 57 degrees. Now they also want us to find the measure of angle DBC, which is actually going to be this angle here. And that angle is along a straight line. So we're going to use the fact that this is a straight line, and these 3 angles are along a straight line. So we're going to take 57 and 57. We're going to subtract that from 180 degrees, and that's going to give us the measure of angle DBC. And when you put that into your calculator, you end up with 36 degrees. So angle A is half of its intercepted arc here, and angle B is going to be formed by this straight angle here. All right, I'm going to continue in a second video, so make sure that you click on the next video to finish the lesson.